Hello,
Hello,
you hear me?
we do.
Okay, I'm not sure where I am now, but yeah, this is the
This
last
fourth,
one.
third one today. I,
No, fourth one. Fourth
fourth
one.
one. Okay.
Because for some reason
Oh,
they're just three slow, but this is fourth one. But this is fun.
yes.
Okay, hold on. I need to set up. Uh,
How many
you
people
take out the
registered for this?
16 last time I checked.
Almost half of us.
10, 9. So you see my slide, okay? So count 11. Okay, maybe I shall start. So it's recording is on, I think. Okay, you can see that it's recording is on. Okay, so okay, let's start some technology stuff. So intro to graph database. So that's something that I personally spent time after I left CA. So it's having fun, but yeah. So but using Fortran and TUI. So just but today, yeah, just introduce what it is, etc. For where it's used, etc. So okay. No, it doesn't do that. Slide doesn't change. Okay, so speaker, well, Kiyoshi is here. So uh, working for a long time for Plex developer, now working for CM Fast, doing uh, PrexWorks as well as owner of EvoBIT, and we use the graph database as main storage for the tool. So just to introduce that today. And here, it's no speaker, but it's a Thai which I work with for this EvoBIT project. And then he could add some fun activity stuff for today's conference, so just to introduce. He's in Vietnam, by the way. Okay, but didn't put anything. Okay, start with what graph database is. So, okay, so we're talking graph, but that's not the graph we talk today. So this is chart. It's just a visualizing data. I mean, with pie chart. This is not the graph. So, okay, so graph. We talk about especially like it's called labeled property graph model. That's kind of the terminology people use. So it's just node and edges relation and has properties and the labels. I come next slide for the detail. So node is kind of entity data. So your person or customer or whatever, that's a node. And then a node has connected with other node with relationship. So relation is always have from or source node and target node. So node can, a relationship cannot exist with one of those. So it has to be always pair. It's connecting. Well, below example is so Abraham follow Kiyoshi and then since today. So in this view, I think Abraham and Kiyoshi is node and the type of person as label, okay? And then follows is type of relationship. So relationship label as follows, and then property called since date. So that's kind of basic idea of those four terminology. So it's repeating, but label is kind of type. You say entity name, I think, and node is actual data record which represent that entity. And edge is always from source and target connection. And the property can be both for the node and the edges, but it's just a kind of simple key value pair collection. Yep, okay, go into same thing, maybe repeating. So that's a very minimum contents of a graph model. And it's really same as like if you create a collection in your program memory, etc. So it's almost it's stored as database. So yeah, I mentioned here. So node label person has property name with value Abraham. And node label person has property name with the value of Kiyoshi. So that's two circle represent. And the edge label follows has a source node Abraham and the target Kiyoshi. And then the since is property and it has value date. So that's the representation. Okay, well, so CFlex object and triple or even 2E, the 2E, is that called triple? I forgot, but yeah, that's kind of surface-wise, it's graph. So object equal node, and then label equal object type. And the AD or panel design or narrative, etc., the property of node. So property of function, property of the panel object. And then triple is obviously edge. So you have source and target always. And a triple type is label of triple, like a function call function or function is a function. Those are label. And then continuous triple, you could think about that's a property for edge. So it's like a Plex triple or Plex data model is kind of represent as graph data model as well. Of course, low level, it's very atomic store, and it's not doing the property way. It's just a very atomic level of management, but that's how things make familiar, I think. Okay, then there's a couple of types. So I mean, directed or undirected. So focus for the relations edge. So there's a two type. Well, it has direction matter or not. So if you are friends of Abraham, then both are friends. So it's a Facebook kind of. So there's no direction. But directed, like Twitter, if you follow, but the other guy doesn't follow you. So that's really matter what the direction is. So function call function is directed, of course, because A call B, but B doesn't call A. But you need to have a B call A relation. So that's how you do. Okay, I put the activity first, but I hope everyone get link to the graph database, I hope, or I mean, above YT. Just put the PDF to the chat, but you can read. I can go through now, but I just share anyway. Okay. So link is here. I mean, if you open the PDF, that's there, and the user password. And so it's just activity goal is so just to create some meaningful image of diagram using available options. So like this one I created, so US airport. So function equal airport, but if you just do some fancy way to location, etc., then it looks like a US geographic thing. So there's a so we provide a UI to insert simple relation. You can create a node on fly, just any name and description. Only open to the two type, menu and the function, which doesn't matter. So you can give different meaning for the different type. And we have three relation available. So two recursive way, and then one just the one layer, single layer, because it's just connecting to two different types. So if you click the menu of that insert relation item, you get some panel, and then you select the edge name in the middle of the dropdown, and you type just your name of node, source, and target, and it's insert a relationship for between two. And all of you sharing same database, so you could mess up someone else's node, but that's just the fun part. So, but it's not isolated at all. It's there. Okay, so node name is kind of primary key you could send, but it's just unique, and you just if that new name you give, it's automatically create, and if that you give the existing name, then it's just to connect to the existing one. And you put the description, and very first time you need, but if second time, you don't need to provide description. If you provide description, it's override description for you, but that's very minimum. Okay. And if you come to see the diagram, you have options. So you go to the function menu, and then type your kind of starting point, whatever the node you're interested in, and search, and then you can open your diagram, I mean, for that. And so this way. So this is kind of interesting way to show. So this is the relation I made, put so SA4 to Chicago and Seattle, etc. So this view itself, well, does tell something, but if you just rearrange data location to this way, it's totally different meaning for human. I mean, it's not for the computer system, but if just you can imagine the Google map is doing this exactly same thing. Just each node has geographic address on that, and then there's a framework they probably have to map, apply to, and then point to. So that's why you can switch the satellite or whatever, doesn't matter because it's just a point using the geographic, GPS address to point there. So, but that's kind of one of the power of the graph, and the visualization is very important because you can show this as table, but it really doesn't ring a bell. But once you allocate it with like a location, etc., or the way you want to show something with embedded, and a human brains kind of react. Okay. Okay, and you can save diagram. So by doing drop down layout, drop down, and you can give a name, and so also you can adjust the layout by mouse different position, and you can show hide node. If you get some extra node, you can hide it by remove, and edge as well. You can remove the edge as well, and you just make some nice stuff. And once you saved, it's saved, so you can just keep auto save option on, then your diagram is kept safe. And if you go to the right top corner of menu under the human person icon, and there's a diagram viewer available. And if you click that, my airport sample is probably there, so you can open my diagram on by yourself because I just share. So we can use the similar thing. So if you just work privately, just draw some nice diagram, and then once you're done, you can click check on that, then other people can see it. Okay, then maybe we decided what's we maybe have opportunity to explain what that means and what's good and bad, and maybe we can send T-shirts or something to win our the best guy. Well, maybe most of you maybe have T-shirts, but yeah, for your kids or life. Okay. So to do so, I recommend just the two open browsers. So just one for the relation adding and then one for the diagram. So you can duplicate your tab and you can have two sessions open and just side by side. So you can add data, you can adjust the diagram and save, just to repeat. I think that's my recommend. Okay, that's activity. So you can run on background or you can start later, but I just continue the slide. Okay, let me know if you have any questions. We have time later. Okay. Okay. So back to session. Okay, so where it's used. So there's prepare some obvious usage. So, well, these guys using, these guys making own graph database, and then some are open source available. They make it available for open source, etc. But it's very instantly. You can imagine the Facebook, LinkedIn, Twitter is graph. So it's no doubt. Yeah. So just very good to represent the recursive relationship with very flexible manner. Okay, and the recommendation, that's the other thing, like Netflix or those probably Amazon or whoever probably using it. So it is very simple, but there's a user one and a movie, and then if I see the certain movie and the type of action, then the other person seeing that movie maybe like those. That's kind of recommendation, but reality it's more like they do more things like what time they saw that movie, and if that person have family or single, etc. So they feel quite a different thing to make a recommendation. But the concept simply concept is this just guess same type of person, very similar, watch this at the night time. Well, maybe has kids, etc. Then do the recommendation. Maybe they change the recommendation on the time too. So that's scaring, but that's really not just I buy these two products and then maybe you like that two product. That's not simple. That's time is over. I think if they do more complex recommendation, of course, yeah. Network, yeah, of course this is airport, but we could do map is also one, Google Map. So map is interesting. So if you search it, so you can imagine the map has kind of a map. In the map, I think location is node and then road is edge, very obvious. And the edge road have a kind of property you can think of like a time takes from A point to B point. So you can have a property of time, also distance as well. And then what you could do is if this road is closed, so you can the kind of single point of failure kind of concept. So if road is closed, that means the edge is not effect right now, active right now. If you flag it, then it's trying to find out a different route. So that's kind of how you get. And also, they gave like a time sensitive, the duration, so nighttime or rush time or maybe live data. So that's why you could consider the both time to take and distance, and then you could get the recommendation for that. And of course, the bus only running on the daytime, etc. Not midnight. You don't see the bus option. So, but the foundation is kind of that thing. Of course, they cache a lot, of course, because people get the quick answer, because you cannot query it very quickly for the US roadmap. I want to go from here to there without cache, but of course, the huge user helping to make a cache build, I bet, but that's kind of. And yeah, single point of failure, it's if you create a graph of network switch your, organization, or even pick a crowd drawer. If this guy is down, you can plan, oh, this guy is not get the power at all. So you can make some plan, etc. You can simulate things like that as well. But same for supply chain. So you have factory to truck or in a warehouse, you could rearrange supply, where you get this parts from there. If this one down, to plan to redirect to others. Yeah, it's data-wise and also lots of help with the visual as well. That's the key thing. Okay, so fraud detection. Well, this one pretty obvious. So same guy has same phone number and the same social security and same address. And then one guy or both guy may be the fake people. So just picking up stuff. They do quite lots of things like a credit card used. I mean, these days you get notified by a credit company if the suspicious activity is there, and then they surely are using this technology to detect as much quick as. Okay, well, little relation, RDB and graph comparison little bit. So I say starting point, so it should be coexist. I don't think it's just to replace one the other stuff. So because the transaction, etc., RDB is better, but yeah, better place the graph is better both. But just simply say, real world is actually easy to describe as graph. You cannot describe the real world with RDB because you need to assign everything to key and the relationship, etc., join key, FK, etc. That's no way to do. But I think easy. If you have kids, you tell you have pen. That's kind of already graph relation. You don't need to you have foreign key of who has parents, etc. The paint shared by multiple people, etc. That's naturally, everything is graph model can probably describe. And also the tree versus the recursive nested relationship. So yeah, so that's the other thing. So the world is not always clear organization chart like. So it's come back to etc. So that's the other thing. And yeah, it's recursive anywhere. So this is not the great latest, and of course it's provided graph side of people, but yeah, if you have a join depth 5, and yeah, so graph return to second for the 800,000 database, but relational cannot come back. Yeah, so that's probably just using, say, simple inner join, but I think I forget how many depths you need to reach everyone in the world using Facebook, but it's not takes too much depth to reach all the people you can reach using Facebook. Like 5 or 6 steps may be enough to reach everyone in the world, maybe. But that's kind of tell if you go depths 1, 2, 3, the more data is coming back and the more self-join to that person, friends or person table required. So that's kind of, it's kind of mean to do that. That's why, of course, graph can return. So like this is other simple thing. So I calling a function just a 10 layer or 9 join. So if you want to extract this data using RD, I mean, left hand is a simple relation. So this is self direct relation. So inner join of a function key as function key. But A call B, well, that's fine, but B then C and C then D. So you could write a quite long join statement, but that's not the case because it's mean to. Okay, so just a comparison. Yeah, it's a new. Well, it's not that new, but it's relatively new compared to RDB. And yeah, use traversal, but use join the other side, and join with edge. So it doesn't care who are you to connect. So it doesn't use FK to join. So it just physically kind of attach to node using edge. So that's why, of course, it's quick because once the point of graph is you need to reach the starting point you are interested. That's the most time consuming part. You look for the certain starting point like SFO, etc. But once you reach it, all the data is just your neighbor. You connect it, so it doesn't need to it's physically connected. So you don't ask the database engine work hard to grab the same key information from that place. It's just a collection and a connection. So and relatively flexible to change data model. It depends on the graph database, but it's very easy to add a new column. And some database allowed to have a column only exists the specific node, I mean specific data. So it doesn't preserve the column for all the record image like RDB required. Well, not best for transactional data, but yeah, I think, but not the other side is not good for deep recursive. And yeah, query is object oriented, which is you just a kind of query following node and the edge and node and the edge. So you query like a really physically looks like querying the relationship. But yeah, SQL, it's a standard SQL, which lots of people familiar, so that's why no problem. But yeah, very first time if you see without knowing both, then maybe graph, maybe I catch it first. Well, the other thing is still little new, so many variations of query languages. So don't say it's standard one exists. where they try to, but it's still not, I think, standard graph query language. Yeah, so graph itself, I mean, modeling wise, it's very easy, very straight to visually, it's very straight to understand. And the performance for those recursive or traversing is crazy fast. Yeah, and so that's about and AI friendly. I'm not spending time with AI or deep learning, but you could imagine the like a path judgment is what the like a conditions and go this way or that way. That's kind of a deep learning or AI is doing. So the data is kind of already set up that way. So if you feel that, then a graph is very friendly to find out the best path, for instance. Of course, you can create that model from relational too. But I'm not sure this is very true at this point, but just found some code for the graph, so aggregation, like a get summary, etc. Because it's meant to like get the relation from the starting point. That's very strong. But if you just carry the summary of, property of this single node, that's maybe a little weak than the relational database. So it's different languages like Gremlin, Cypher, GQL, they call it. So Graph SQL called GQL. Okay. And just go to visualization a little bit. Okay. Oh, sorry. Yeah. Just first, just a different type of graph database in the market. So these are available. Provide using OrientDB, which is SAP is owner. Neo4j data stacks, which is Cassandra owner. So those are very big, giant stuff. When I go to the graph conference, these two are always there for since very early time. Well, yeah, Tiger. Every time you see some new vendor, but it's very competitive and yeah, it's there. The people doing that. Okay, so yeah, provide using OrientDB, the function call graph, and recursive, etc. So that's how we doing, and yeah, we could see that most of our graph database provide a web UI. You can run query. You can basic visualization of data like this, and also you can see the table like data. So and also maybe command line console as well. But we have used these to check quickly or do testing the query is syntax wise good or bad. But yeah, okay. This is pretty much like normal SQL, but that's only in DB query arrow. So select star from person, then just return the person. That's very same as SQL. So OrientDB kind of provide a very close to relational SQL like syntax. So second one is very same. So person, but where name equal Kiyoshi, then you get the one instance. But if you go to the graph query, then slightly change. So gonna do the match and class. This is label. Oh, sorry. Function and where the name, etc. And then this is the other thing. So dot out. So from this starting function name AF and going look up the out relation to this particular edges, then you return, and then you can provide depths here. So this is the difference between the join, multi-join versus just simply you can give a depth. So if you do 2, then you just go to the query the 2 depths from this starting point. So if you can give 10, then it does 10. But you don't need to do the joins. So that's very simple, and this kind of eye-catchy, I mean, very obvious what's kind of this one try to do, even you don't know. So just the starting point and the function called function relation depth 2. So then you get some result. Okay, so yeah, A2F calls 6 other functions, then call other total 10 functions, and you get 11 functions, including yourself. That's the instant case, and you can increase depth this way. Okay, then a visualization. So use a open source project called Sidescape.js. It's a JavaScript library, very focusing to the graph visualization. And you basically gave node ID and edges with source and target ID. So that's very minimum set of components. You just a list of nodes and list of edges. Then this guy will consume that and then visualize. So I can just do the quick demo for that. So this page you can access, and this one, very big model. But so left hand is red wine and right hand is white wine, and the middle of the yellow is cheese. Okay, and then well, if I select one cheese here, so it show up cheese, some kind of, I don't know. I'm not really cheese person, but that's something they tell. And oh, sorry, I shouldn't click the button. And if you select the white wine, then it show up the matching cheese for that white wine. So someone created, but that's the this diagram does. So you see the very big image first, and then you click it and then focus to the middle. That's kind of one way. And this is like a Tokyo train system. So it's kind of similar to the map, I mean, Google map, I think. And you can define starting point, and then maybe you put the destination. So then highlight the way to go. I think this one probably using just the shortest path. It's not doing anything smart enough, but yeah, but that's just highlighting, etc. We take this idea to level by T2. Yeah. So yeah, you can do quite nesting. So this has a node has parent-child kind of relation, so you can contains nodes and edges within the node, so you can group things like that. So that's just like you could use like this physical location, and then you could put like a computer system or network, etc. And then you can do lots of things. Okay, so this is kind of available as a foundation sample, etc. So that's we kind of using. There's a commercial version, of course, always, but this is something we use for the data. When we show that, we provide ID and the source ID and target ID. So that's enough to draw the two node and then connection. And of course, you put the different properties to show up to the different location, but that's just minimum. So list of nodes and list of edges, and provide data. Yep. So just complicated stuff is down there. Okay. Am I too quick? Yeah. Okay. Okay. So there's a lot of comparison graph on the RDB. If you go to look up, many says RDB can do it. So, well, that's true, but yeah, it really depends. Like some people just protect your things, that's why you could say. But the really only truth is there's many giant, big company is actually using it, then all of us probably already get the benefit of that. So that's no doubt. So it's use cases there and they actually use, it's used. You are using always daily without knowing, but that's very true statement. So yeah, it doesn't replace your business stuff, but just to think a little bit, maybe just how if you dump out some historical transaction record or anything, dump out to the graph side, and then you maybe find some nice stuff built up. So that's the idea, probably lots of things. So. But yeah, so that's the thing. The logistic, etc. Yeah, that's pretty sure the idea. Okay, gonna do activity, but you could ask question or comment, etc. It's very open, and I like this session because it's very something fun part. Okay, fire? No.
So as we discussed in the previous session,
Mhm.
have they benchmarked instead of join, have they benchmarked the hierarchical SQL statements?
I don't see that. Yeah, I haven't taken a look. Yeah.
Because I know Microsoft and IBM added them both to their database engines.
Mm-hmm.
So if you've got it and you don't need heavy intensive graph database,
Mm-hmm.
it is a way of doing a little bit of hierarchical
Yeah.
without reloading
For the
data.
existing data model, maybe, if you have that kind of relation. But same time, Microsoft has its own graph database, I guess. So it's an Azure something.
Almost any company has something if they think someone will pay them for it.
Yeah. Well, buy, yeah. So.
None of the other participants, any feedback?
Anyone has access to these things?
Don't know about anyone else, but I do.
Yes, mine's working.
Actually, I can check who is logging in. Okay, I see it all. Roger. Yeah. TUI from. Yeah. One. Boise is added. Good. Yeah, it's 4 to Boise. Then I think I can do. Okay, Indiana and Boise is there. Boise around here. Indiana kind of here. Yep. So yeah, I think just open your browser display, then you can add something to your stuff. And so good have GGGC called GGGH, and then add it. It's added. Gonna see this one. But I opened function call graph one I made, and so call C to H. Okay, now see the shortcut one here. Override. Okay. Tempo is around here. Where's the tempo? I don't know where. It's too crowded.
You need to push Indianapolis a little bit east. Or it's not that close to JFK. Yeah.
Am I the only one adding things?
Graham, play this other part, or you can feel free to play other section too if you want. Yeah.
At least to that repository, apparently.
Hmm?
Looks like you and I are the only ones in that repository. Added by
Yeah.
administrator, added by Jay Stent.
maybe share the raw database. So this is the actual database on that VM, I mean the hosting machine. So the like so this is a list of node vertex and a list of edges, and we have different type of objects with this entity or DB schema, so 497 like this, and these are the edge count. So all the edge total is almost 20,000. So they have like a concept like inheritance. So all the edges based on the E and all the vertex is B, and you can create a middle layer to do like here we created an entity relationship. Edge is then owned by entity, so you could predefine that kind of Java or object-oriented like meaning. If you just query function, we get the star from DB schema, and then of course it doesn't return everything, but yeah, 2000, but it's, we return 20. Okay. I shouldn't do 2000, but JSON. So read the data, and you could see like a detail, like a regular thing. So this is table view. I mean, a record view for the this particular record, and this particular database manages the data with this called RID. It is like a storage ID and the index is with it. So that's not for you human, but that's the true unique identification they protect. And all of these are property, and so we kind of preset things like that. And it has relations here, view based on table, and expand. So this has like an outgoing edge exists and code view based on table. So this is the type view. If you go there, so this is what was view, and then this is the table. So this is the relation record view, which has no property here, but you have property, it's appear here. And yeah, this is the other side view table, and the table has its own data. Like this part is like a relational data, but only difference is you have different edges stored as like a list. So read has sorting edges, and then you could go up for the function. Well, this will count, and you can do the function now. So it's very flat, but that's kind of how the data is actually stored, and you can see it. So then once you are in the function, so function calls, this one called by one function. And then this one doesn't call any function, but have nodes and reading one data and then update one data. So that's about, and if you go up, you see the same thing, the functions, and it's okay. Now this one called by 7 functions. So that's how it's stored. It has simple graph viewer, so you can use that ID always. So name. Okay. Select that one. Yeah, so this is the my function starting point, and this is similar. We can expand to the other stuff visually. So that's come from this database UI, so you can just visualize what these relations, we can go up. Yeah. So 3 function more. It's already kind of recursive and we're calling each other is appear here. So, but that's the basic. Just maybe like this. So this one holds a very long property called content and storing the SQL text generate as a list of string, I mean JSON format. So you can see here the content. So storing that is showing up on the UI too after pausing. So yeah, you could store like almost anything you can think of as property. But okay. And well, I probably repeating things, but we start using uh, so this is the other technology we use in backend of IT. So we're using Elasticsearch to create an index for the action diagram when we loading. So you can search like you do search on Google kind of. So you can search if the select where statement is used in the function, any local action diagram, then it's just to come back immediately. So that's the other one, other technology we kind of start with up. It's still running a lot about how to provide, I mean, string search query format because they arrow to many different uh, way to query the string and yeah, creating index, etc. But it's the other things we really focusing on. So you could search uh, action diagram text with a statement or comment or values, etc. They come back immediately. How is activity? So let's see some well airport is growing. San Diego is adding. I'm going to Vegas. Okay. So like this one maybe has some very simple built-in. So you select the start and select the end. So it's find out the shortest path. So it's not useful for Pred, but at least it's finding out the shortest path. So let's say so Lux is damaged. Okay, so now if I do same way for start and end, well, this is the next, now this is the shortest path now. So because Lux is down. So it's not useful for function call, but I just thinking how it's useful, but I found one article says this is used by like a Google Map, etc., at least to find the direction. So the shortest path direction is from east to west, etc. Then they could get a big hint of like how you carry the starting point to the next one. Because if you know that the GPS RS compare with between two and found, and also the route, I mean, you probably don't need to go to the like a backward kind of path you can throw away when you carry. So that kind of one way to use. But anyway. Bring back the rocks back. Um, the other thing doing here, if I select this before, and if I select the JFK with this, and so we just pick up all the route to go into the JFK. So we don't have a weight here, but if the route has weight, we could do something better to highlight like a shortest distance time-wise, etc. But yeah, this one tells all the route from here to JFK, and of course there's a shortest path available. Well, I think if it's find a two or more, maybe just pick up one, some logic there, but at least it's just one stop. There's no direct, looks like. So that's okay.
How hard would it be to have made that link a bidirectional link? I mean, we're using function calls function, which isn't really true for airports, but
Yeah, it's not true. I think data-wise, I think it's always directed for this particular database, I believe, but there's a query you could do out or in or both. That's three type of the query available. So if you do like instead of out, if you do both, you can get the kind of both direction. You can treat kind of like it's not dimensional. And also, yeah, it's really up to you what kind of arrow shape you use here. So if you get rid of this arrow top, then just make a line that's really feel like directed. So there's like a lots of shape provided. Yeah, like a dot or you can think anything. So there's a many style available. You can point to the different arrow head and the root head, etc.
That's a kind of a adjusting depth when you query. So this is 0 and like 1 depth and 2 depth, or then you go full and go into everything. So that's just adjusting the depth of query using relation, then you get the return. So this, of course, this visualization data doesn't know everything. It just knows the list of these purple nodes and just the list of lines information. Then it's automatically layout. Depends on the layout style you pick. So we're just using two vertical and the horizontal, but of course there's like a donuts bar like view, etc. It depends on the what your data and the meaning to tell to people. But, okay, half still. So more.
Okay.
Embed the pie chart inside. Okay. Oh, okay. I don't. Yeah, very clear now. I think. Okay. I think that's all I have. So could leave or yeah, you can stay, talk a little bit. You can continue demo. Just to wait unless you have anything want to talk. I can continue just to play with it. But yeah, thank you for joining, and I hope at least you get something new and just to consider uh, consider apply this to your business, etc. And yeah, maybe able to help a little bit. But the things are lots of graph data, of course, try to steal the customer from RDB. So they have a bunch of import capability available. So you could just tell the JDBC driver information to the point to your data store. There's a data import feature to give a try, kind of, and lots of vendors provide a free trial version and a free trial period with enterprise version, etc. So that's the point just to catch you, of course, if you start that. But there's a bunch of things you could give a try. And as far as you install on your in-house system, they don't steal your data. So yeah, that's the other thing you could try. But yeah, it's ready. I mean, you may see the data different way, but something maybe ring a bell. Yeah. And also you can connect to the external data too. So we connect to because like all of LinkedIn, etc., have provide API to you to carry their data. Right? So I don't know, it's personalized or private, but you could get data from that, and then you can connect to your customer database, etc., to there. And one of the usage kind of like how it's a big market for the master data management right now, MDM, and because like some specific area like a medical area, so you track doctor, you track the professor, or you track the salesman for the medication company, etc. They don't provide always the up-to-date information to you. And there's some database available that it's very hard to people move from this organization to the other organization, etc. So it's very hard to track. But yeah, some software does that. Is people, I mean, those data identify those, for instance, professor in the Facebook, and they detect more like a private information. If you find the same person, same name person appear in the different data, and then matching this person, maybe that person kind of thing. And then maybe 60% of rate, this is same person. You want to update your database using this new data. You ask it, and you set the 80%, you trust your AI, then it's automatically updated. So there's a bunch of public data by a organization over something, some medication group, etc. So it's just to correct everything, and then matching the family structure, etc., and then geographic, etc. Then they kind of automatically updating your data under the cover. And the only fuzzy thing it's asking human to confirm. So that's scary, but that's kind of thing really going on. And of course, the graph is one of the many things to doing that.
Thank you for that overview, Kiyoshi. I hope it's been informative for other people as well.
I hope so. Rob, you're quiet. I met the Rob Razel the other day. So yeah, it was good. It was fun. The data you had a presentation in the one of the seminar, same day I just met Rob on the street. Okay, I keep this session open, but feel free to leave it, and if any feedback, question, I can answer. Thank you.
Thank you, Kiyoshi.
You.
So Roger, who is the CA2E track? The Mark?
Lokesh, I didn't hear your question.
Hmm?
You asking me a question?
No, I just wonder who is the CA2E track. Yeah,
That's me,
Yeah.
John.
I didn't know you. Yeah. Okay.
All right, so I guess we have a wrap up at 4 and then.
Yep.
That's it. So you and Roger coming together?
I'm here. Yeah.
Oh, good.
I can,
Yeah, Abram picked me up, so Roger, you could go by yourself.
oh, Abram's going to pick you up. Okay.
Yeah.
Okay.
Did you see the note on the calendar invite?
You mean the location? This one?
Yeah.
I saw, but yeah, I think
I'll send I'll
that's
send
why
more
Abram
information.
mentioned, that's why. Yeah.
Okay.
Oh, okay. It's almost over.
Okay.
I still not feel running. So how was your day, Roger? You muted?
Yeah, it was good. Yeah, we
Good.
didn't have a lot of people, but good questions, good sessions. Pat gives a
Deep,
really good
yeah.
overview of the RPA. And then
Mhm.
Dario went in some really good depth in error handling and logging results and showed us, several things that you can use in a lot of different ways. So it was very good, more in depth than I had seen.
Yeah, small group can go deep, right?
Mm-hmm.
Yep.
Yep. How about your
Oh,
analysis, Evolve ET analysis session? That go well with John?
very fast one? Yeah, I think so. Because
How many people joined that
didn't,
group? Large group?
I forgot. Yeah, I think basically almost all clicks people, but I forgot to see the count. This time not. I couldn't.
Yeah, I could go look and see how many
Couldn't
logged
pay
in,
attention
right?
too much things. Yeah,
See how many
I
people
couldn't
logged in.
couldn't pay attention too much different things. So.
A lot going on, yeah.
But I did similar for 2E as well. Yeah, 2E and the Flex do the same thing. But when I saw the last time, it kind of disappeared.
What's that?
Is there like a door? You still be able to see it on the past event?
See what?
Past event. I mean, when I see all the previous meeting is kind of disappear
From
from the
Zoom?
view.
Oh,
Yeah,
I still see
from
them.
Zoom.
I'm logged in. I still see the
Okay.
robotic process, and basic and advanced, and this graph
Oh,
session.
okay.
Yeah, they're there. I don't know if it didn't update yet. Maybe if it updates somehow, it'll drop them. I don't know. Okay. Good day.
Ah, yes. Good day.
Going to, what did John say? It's the broken spoke. Got to take your hat, your cowboy hat with you. He said we're going to get pictures.
Ready? Okay.
That's what he said.
Yeah, okay. Yeah. Okay. We have wrap up, right?
What's that?
I think. We have wrap up.
A laptop?
final wrap-up. I mean, a final ending.
Oh,
closing
way
session.
to get connected. Yeah, I actually use my other RPA development server, and I logged on
Mhm.
to the lab session from there. That worked fine. So I can get to the RPA
Okay.
development. But
Okay.
I
Remote,
couldn't get to
remote.
the Azure for some reason. So yeah, I don't know why, but it worked fine to do it that way.
Okay.
So the Broken Spoke looks like South Lamar. There's a lot of broken spoke, some things, but Trail Station, Canyon Lake, Broken Spoke, Texas. Broken Spoke Trail. I guess it's here. Obviously in town here. Street view looks like there. Okay, so it looks like a bar and grill, yeah. It's actually got an indoor picture. That's nice.
Mhm.
I hadn't seen this before. They've actually got an indoor. You can walk around indoor in this location on the Google Maps.
Even yesterday's location was some indoor table open, right? Yeah.
Sorry, I'm not hearing you very well. One of my earphones stopped
maybe-
working. It's just kind of muffled a little bit.
Okay.
Anyway,
Well, I don't know. Maybe my side the battery maybe.
yeah, I don't know.
Yeah, run out maybe.
I don't know.
So usually whole day. Yeah. Okay.
All
but,
right, yeah.
Yeah,
Well, I
thank
guess
you.
I'll see you there. You said Abram's
Yeah.
picking you up.
I think so.
All right. If he doesn't,
All right. Yeah.
okay.
If he doesn't, I stay here. Yeah. Okay.
Talk to you later.
Thank you.
Bye bye.